So question 4, it says show that the sum between 1 and 16 of that expression there, 3 plus 5r plus 2 to the r, is 131798. So what we can do here, it's a show that question, so we need to show full working, but we've got to notice that this bit here is an arithmetic sequence, but this bit here is a geometric. So we're going to have to use two different formulae here. And the formulae are in the formula booklet. You should always, as I've said in previous videos, have the formula booklet to hand when you're doing these questions. So there's the formulae that you're going to need to use, just on the right there. Arithmetic series one is there, and the geometric one is there. So we're going to separate this into two separate sums now. We're going to have the sum between r equals 1 and 16 of the arithmetic part, 3 plus 5r, plus the sum between 16 and 1 of 2 to the r. And let's call that part A for arithmetic and part G for geometric. So A, well, for the arithmetic part, when r equals 1, we can see the first term is 3 plus 5 lots of 1, which is 8. And the common difference, well, every time we add one r, we add 5 to the expression, which means that S16 is 1/2 n 2a plus n minus 1 d equals, then let's put that in the calculator. So that becomes 1/2 n 2a plus n minus 1 d, which is equal to 728. So equals 728. So let's move on to the geometric part now. So for the geometric part, when r equals 1, I can see that the first term is 2, and the common ratio is also 2. So that means that S16 equals, then subbing it into the correct formula, equals A, 1 minus r to the power of n over 1 minus r equals, so type that in the calculator now, so 2, 1 minus 2 to the power of 16 over 1 minus 2 equals 131070. Therefore, the total sum equals 131070 plus 728 which equals 131798 equals 131798. Just check that's right, yeah, 131798. So what I could have done, just to check that the individual parts are right, in the top right hand corner here, if I press shift, then this top right hand button, I get the sum function. So I could have put 3 plus 5x between 1 and 16 just to check that my 728 was right, which it is there. Likewise, I could do it again for the geometric one. 2 to the power of n, so 2 to the power of x between 1 and 16, and hopefully that'll give me 131070, which it does, so that's a way of checking individual parts of the answer. Right, so the next part, and I'll just copy it here so we can remember what it is. There it is there. So it says a sequence is defined by that there, so the next term is 1 over the previous term, and I always like to write these in words, just to make it a bit easier. So next equals 1 over the previous, and tells us the first term is 2/3. So find the exact value of the sum of the first 100 terms of the sequence. So u1 equals 2/3, u2 equals 3 over 2, the reciprocal of that, u3 back to being 2/3, u4 3 over 2. So just going to continue like that. So really we can think of this as 50 pairs of terms, 50 pairs of 2/3 plus 3 over 2. So 50 times 2/3 plus 3/2. We'll say S equals, let's just pop that in the calculator, 50 times 2/3 plus 3/2. And there's our answer. So 325/3. And there we go, we're done. So that is that question there done. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.